questions as well. Alrighty. For those of you who are watching on YouTube, welcome to the statistics lesson. We're using the Sharp calculator and sponsored by Sharp. We're going to cover lots and lots of stuff today. So we're going to cover from grade 10 to grade 12. It's a massive topic. Hopefully we'll do it some justice. It is a good revision of everything, and hopefully there are enough example questions for you. So yeah, stop me if you get stuck somewhere. But the first important thing is that statistics is the study and analysis of data, and it is a very, very useful topic. In fact, I did my degree in it, so I love stats. I think it's awesome. And it helps us to make informed decisions, to calculate risk, and so on and so forth. So they use it in research and in the analysis of big data. And one of the top 10 jobs, up-and-coming jobs at the moment, is data scientists and data analysts. So that's all using your statistics function and big salaries that go with it. So something to bear in mind if you're looking for a future career. And stats is such an interesting topic, so much stuff that you can cover. So awesome. The calculator we're going to use tonight is our old favorite, the Sharp ELW535SA. All of the statistics functions that we are using tonight are also available on the W506 if there are any IEB people joining us. Okay, it has an unlimited table mode, highest common factor, lowest common multiple, easy to use stats. I'll show you that during the examples, and lots more functions that just make it such a nice calculator for CAPS and for maths in the South African curriculum. Cool. So firstly, what is data? So data is the information that we get from doing research or an experiment or from observations. So if you look at my picture on the right, it's the position as well as the salary and the office and the extension. And of course, all of this is different information. So we can count cars, we can count people. The position is a type of data. The salary is a numerical, quantitative piece of data. The office is a qualitative, it's a location. And your extension number, probably more of a qualitative than a quantitative piece of information, because it's not really a number, it's the phone number. So that doesn't change, if you know what I mean. Okay, so and then of course you get grouped and ungrouped data. Oh, pardon me. Not enough coffee today. So where your grouped data, your ungrouped data is basically your raw data. It hasn't been sorted out. It's everything that we see, whereas group data would be where you count everything within a specific interval. So we'll look at that in a little bit. Central tendency, what is it? It measures this middle of where the data is. So if you look, we have a mean, which is the average of the data, and you calculate this by adding up all of the data points and then dividing it by how many data points there actually are. The median is the exact middle point of the data. So that's counting the number of data points you have and finding the exact middle of that data point. We'll do an example just now. Mode is the piece of data that appears the most. So it's that spike, or it's when you have a data point that repeats itself several times. That is a mode. When we are talking about group data, it is the interval with the highest frequency. So, Malinki gets the following marks for her 9 assignments. She did very well. Oh, I haven't taken out that 74. Okay, please ignore the 74. It should not be in here. There's 9. Okay, so the question is, what is the mean, what is the mode, and what is the median? Okay, so obviously the mean, we're going to add all of these data points, and then we're going to divide by the number of data points there are, which is 9. Your mode is the one that happens to appear the most. So if we look through our data, we can see that only 75 repeats itself. So we've got a 75 there and a 75 there. So our mode would be 75. And our median is the middle. And I'll show you how to do that in a sec. Let's just go through to the next page. So Oh, you see, I actually just copied the same screen twice. So that's why all right, cool. So the mean, firstly, we add all of these data positions together, and I will show you a shortcut for this in a little bit. And we divide it by how many there are. So there were 9 assignments. So we take the sum, we divide it by 9, and we get 81,44444. That should actually be 44. Sorry, really should have gone through this better. Then again, we look at the mode, and we said the mode is 75 because it appears twice, whereas all the other data points appear once. Sorry, I see these just on the screen the whole time. Alrighty, so now we want to know what the median is. So with regards to the median, we first need to put the data into ascending order. In other words, from the smallest data point, or the lowest mark, to the highest mark, okay? So from smallest to biggest. So I've done that for you here, okay? Just arranged it nicely. And then there are 9 data points. So our formula for the median position is the number of data points plus 1 divided by 2. So 9 plus 1 is 10, divided by 2 is 5, and then we just go and count 5. So 1, 2, 3, 4, 5. And so the median is 75. Okay, and we saw that 75, and it's particularly obvious here when we've arranged the data into ascending order, that we can see our mode as well. So it's always a good idea before you start anything, if your data is not in order, to definitely put it into order before you do anything else. Okay. Cool. The next thing that we need to look at is range. So range is to find the lowest value for our data, which is the minimum, and the highest value for our data, which is the maximum. I see there's a question here. Yes, and I do agree. It is the best advice to arrange the data first before you answer any questions. And then, sorry, so to go back to the range, we need to find the lowest value for our data and then find, which is the minimum, and then find the highest value for our data. Then our range would be the maximum minus the minimum. So from our previous example, we had the maximum as 96 and the minimum as 52. So Mandis's range in marks is 44 marks, which is quite a big range. Okay, like a range of shoes. I'm a woman, I like shoes. Alrighty, so the next thing that we need to look at is quartiles. Now, quartiles are the quarter points in our data. And a quartile is basically the median of the lower half of your data, and the quartile 3, or upper quartile, is the median of your top half of your data. That's basically it. So a quartile, sorry guys, a quartile is a quarter. So we use the formula n plus 1 divided by my internet died. So right, we were discussing quartiles, okay, and then of course for the third quartile we are going to divide it by 4, but we're going to multiply it by 3 because there are 3 quarters. Okay, so let's look at our example. I've taken the same data from Malinki, and we're looking at 9 plus 1. So 9 plus 1 is 10, divided by 4 is 2.5, so position 2.5, which is between 53 and 71. Now, to find this, we actually have to take the average of those two. Okay, so we're going to say, I'm going to just grab my calculator. Sorry, I really am having a moment here. Calculator, there it is. Okay, so what we want to do is we want to take the average of 53 and 71. Zoom is really hassling me tonight. Okay, so 53 and 71, and to find the average, we just add the 2 together and then divide it by 2 because there are 2 values. So our quartile 1 is actually 62. And then for our quartile, our third quartile, we have 9 plus 1 is 10, divided by 4 is 7.5. Oh, sorry, is 2.5 times 3 is 7.5. So position 7.5 would be between 79 and 81. So again, we're just going to do this on the calculator. So 79 plus 81 and then divided by 2 is equal to 80. Oh, sorry, it's 82, not 81. So it's 79 plus 82 divided by 2. So it's 80.5, basically. All right. So that leads us to the box and whisker plot. Okay, so we need our 5-number summary. We have a minimum, a quartile 1, a median, quartile 3, and a maximum. These are all box and whisker plots. And then, of course, once we have this information, we can then draw our box and whisker plot. So from our previous data, our minimum is 52, our maximum is 96, our quartile 1 is 62, which is what we calculated earlier. And then our median we said was 75, and quartile 3 we just calculated. So here I've done a diagram. It's not exactly accurate, it's just to show you. So your minimum and maximum are your whiskers. I couldn't resist the cat, makes perfect sense, right? The median is the line in the middle of your box, and your quartiles are your outside lines of the box. So if we draw a box and whisker for this data here, our minimum is 52, so we're just going to put a little point here, and our maximum is 96. So those are our whiskers. Then our first quartile is 62, so here's our box here. And our third quartile is 80.5, so almost here. And let's just draw the box and connect the whiskers. And then our median is over here at 75 in there. So you can see that it's not exactly symmetrical, and we'll discuss this in a little bit, but it's important to notice that your median is not in the middle of your box and whisker plot. And you can see that this whisker here is much longer than this whisker here. Okay, so just things to pay attention to, because those are questions you're going to get asked. I see there is a question, so I'm just going to answer that quickly. What would you convince learners not to draw a bottle in a whiskey diagram? Sianda? I'm very confused by that question. I'm not going to lie to you. A bottle, and are you talking about a box and a whisker? You're just using auto correct. So yes, I would always say draw your box and whisker. It's a very good way to analyze the data, particularly when you're looking for symmetrical and skewed data. Okay, cool. So let's look at the next page. Sorry, now I have the box and whisker all over my page here. Right. Okay, so here's an example where we've been given the box and whisker plot. Okay, and for Danielle's scores, out of 50, she received 20 different dance routines she did over the last 6 months. So give the range of Danielle's scores. So here our range is from our minimum to our maximum. So it's 49 to 7. So we're going to say 49 minus 7 is 42. Okay. The next one is give our interquartile range, which we haven't discussed yet. So I'm just going to skip that question. We can come back to it in a little bit. The next question says, how many scores did Danielle get between 24 and 41? So here we can see that this is 1 quarter of the data, right? Because each of these parts represent 1 quarter of the data. So 1 quarter of 20 is 5. So there are 5 scores between 24 and 41. Here, the next question says, how many scores did Danielle get between 17 and 41? So that is between your lower quartile and your upper quartile. So that's 50% of your data. So that would be 10 out of 20. Okay. What can we say about the spread of Danielle's scores? Again, we haven't covered this just yet, so I'm going to give it a skip. And then if Danielle's top 25% of scores occurred in the last 2 months, what can we say about Danielle's dancing? Well, if all 25 of her top scores, which is between 41 and 49, occurred in the last 2 months, it means Danielle's dancing has improved. Okay. In order to go through to the next round, you need to score more than 40. In how many competitions did Danielle go through to the next round? Well, we can see from here, she scored between 41 and 49, 25% of the time. So she went through 5 times out of the 20. Okay. I am going to erase this so that the next slide doesn't have blue handwriting all over it. Okay. Awesome. All righty. So the next thing that we need to look at is percentiles. So from Kevin Smith's grade 11 handbook and study guide, a percentile is the value below which a specific percentage of data elements lie. So our position is your percentile. So say we want the 40th percentile, it would be 40 over 100 times however many data points there are. Okay. So from the previous example, if we want to find the 33rd percentile, we'd put 33 over 100 times 9, which gives us 2.97, which is approximately 3. So 71 is the 33rd percentile, and if you are below the 33rd percentile, you are below 71. So that's this data here. Okay, so when you are talking about marks and results and all of that sort of stuff, this percentile is what measures that. So if they say your growth is below the 50th percentile, it means your growth is slower than 50% of the population, basically. Okay, so it's just comparing you to the rest of the group. Okay. Cool. So the next thing to look at is histograms, frequency polygons, and ogives. A histogram is a bar graph that represents grouped information, group data, and because it is a histogram, it means there are no spaces between the bars. Because it's history, it happens concurrently or all together. Okay. With a bar graph, your bars are separated because you are using data that is not always necessarily concurrent or can be next to each other, if that makes sense. So for a histogram, you're looking at things like time. With a bar graph, you could be looking at the number of red cars and the number of blue cars, and so on and so forth. Okay. The only time there would be a space is if your particular interval has a 0 data points in it. Okay. So a frequency polygon is the line graph version of the histogram. In other words, what we do is we take the middle points of each bar and we join them together with the line graph. Sorry, I'm doing this very badly. You'd use a ruler and straight lines. So that there would be your frequency polygon. Okay. Now an ogive takes the cumulative frequency. In other words, it adds this bar and this bar together and plots the point over here, wherever it would be. I'll show you one in a few seconds. Okay. Let me just erase this. Cool. So here's an example. Below or to your right is a table with data from the number of people driving under the influence of drugs and alcohol found on crime stats in 2013. So this is from a Maths at Sharp worksheet, just by the way. So look at the data carefully and answer the questions that follow. What scale would you use on the X and the Y axes? So here, our scale, what we would do is use the X axis would be your year and your Y axis would be your number of crime, because your number of crime depends on the year that you are looking at. Okay. Draw a histogram to represent the data. So that's on my next slide. So here we can see we started in 2004. What you should actually do to be perfectly correct is have a little 2 lines here, and that means that you've skipped years before, because we obviously can't start at year 0. It would be ridiculous. So you just say, I've skipped some information between 0 and 2003. Okay, that is pretty much the standard for that. Okay, I want to go back to my previous slide now. Then the next one says, find the average number of crimes per year. So what are we doing? We're going to add all of these up together and look at how many years. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years of data. So let's just do that quickly on the calculator. Let me just move my calculator. Oh man, really? Right. Sorry guys, I'm having technical difficulties with this calculator today. Alrighty, so let's try this for the first time. There we go, there's my dots. Okay, so I want to add 24,886 plus 29,927 plus 33,116. Oh, sorry, I'm on stats. So sorry, if you want to just go home to do quick calculations, just press your home button. It takes you back to normal mode. It's a very nice shortcut. So let me just start again. Plus 29,927 plus 33,116 plus 38,261 plus 48,405. I'm hoping you're sensing a trend here as I'm reading out these numbers. Then the next one is 56,164 plus 62,939 plus 66,697 plus 69,232 plus 71,029. Okay, so that's my sum. And then to find the average, I divide it by 10. So the average number of crimes over the last 10 years between 2004 and 2013 is 50,000 a year. Okay, so that's quite a lot. Now, the next question says, looking at the histogram, what would you say the general trend is and why would you say that? So if we're looking at the trend, we can see that the histogram is increasing. And we can also see it's sort of increasing, but more slowly as we get to the top. It's sort of leveling out here. So what we can say is it is increasing, but it seems to be slowing down as it is increasing. You can see it sort of looks like 1/2 of a parabola. Okay. So any of those answers would be the correct answer. Cool. So here's the next example. The table on the right gives the weights of different rugby players from around the world. Complete the cumulative frequency for the data. So when it's cumulative frequency, we fill in and we add the frequency. So here it's just 4, so we write down 4. Then we have 4 plus 6 is 10. So what we're doing is we're just adding this way. Then we have 10 plus 6 is, sorry, this is dreadfully untidy, 16. 16 plus 7 is 23, sorry. And then 31, and then 42, and then 51, and then 57, and then 59. I didn't make any mistakes, guys. You didn't see any weird stuff, right? Let me just make this an obvious none so you can see that's a 7. Okay, so once we have our data, the next thing we need to do is to draw a frequency polygon from the above. So when we are drawing a frequency polygon, we are using the frequency column and the weight. So exactly like how we did with the histogram, we're going to look here. So it starts at 85 and 0. Then from between 85 and 90, there were 4. Between 95 and 90, there were 6. Between 95 and 100, there were also 6. So it just gives you a general look at what the histogram would have looked like. Okay. Then the next, oh, sorry, let me go backwards. The next one says draw an ogive. Now, an ogive is basically a cumulative frequency graph. So an ogive has a distinctive shape. You can see this one is not a super great example of it, but it tends to look sort of like a pulled out S. Okay, that's what it should look like. You see them a lot in biology, just by the way. Okay, so that's what an ogive looks like, and that's from plotting the points. Technically, again, I was naughty. What I should have done is put 85 here and then done my 2 little lines beforehand, but I was using Word, so please forgive me. All right, so let's go back and see. So now the last question says, how many rugby players' weights are in the top 25% of the weights? So that is your quartile 3. All right, so if we go back to our ogive, we need to find our quartile 3. And we can see that that has been calculated here for us. Our median and our quartile 3 is here. So it looks like it is just at 121 or 120 and a half. Okay, so your top weights would be between 120 and 130. So 25% of the data is here. Okay, cool. Are we all happy so far? Okay, just get rid of all of this stuff. Awesome. The next thing that we want to look at is the standard deviation. So the standard deviation measures the distance or the average distance from each data point or data element to the mean. So our formula, sorry, I see I missed a spot here. Our formula is your data point minus your average squared, divided by the number of data points, that gives you your average distance, square rooted. Okay, so that's the formula. Now, that's a long, we can do it the long, complicated way. Okay, so here's our data points. And the first thing that we need to do is to find our mean. So our mean is adding up these 5 data points, dividing them by 5, and we get 86.4. So what we're going to do now is say 96 minus 86.4, which would give us 9.6. Am I right? Let's just use the calculator. I mean, that's what it's here for, right? So the first one would be 96 minus 86.4 is equal to, I was right. Aren't you proud of me? So that one would be, let me just get a better color here. Sorry. Right, so this one would be 9.6. Okay, then if we square that data position, I'm going to go back to the calculator here, and we're just going to square the answer, and that will give us 92.16. So let's go back here. So this would be 92.16. You can see that this will take us quite a bit of time. And if I was smart, I would have filled in the table for you. So we can do all of those things. I'm not going to do it now. It does take you a long time, because most of the time they're not going to ask you this anymore. I haven't seen this in a maths question or in a final exam in a long time, simply because you can do it on the calculator. So, sorry, let me just erase all of this before we continue. So you do actually have the ability to do it on the calculator, and that's what I want to show you now. So on our calculator, we have stats mode. So we're going to say mode, 1 for stat, and then 0 for single data. Then we just type in our data points. We're going to say 96 equals 60 equals 98 equals 91 equals and 87 equals. Now, incidentally, just because I see it here as I'm thinking about it, did you notice that there are no repeats of any of the numbers? So here, when they ask you for the mode, there actually isn't one. In fact, all 5 are a mode because they're all repeated the same amount of times. Okay, so now that we put our data in, we can press change, and then all we have to do is press alpha and 8 and then 0 for your statistics value summary. So here's your n, which is your number of data elements that we typed in. Your average is 86.4, we worked that out. Now we don't use this SX, we use the sigma x because of the type of formula that we're using. So we always use this value here where it's the sigma x, so it's 13.75. So that is your standard deviation. And then of course you have some other fun things. There's your sum of x, I'll just go through it all, your minimum, your quartile, your median, and quartile 3, and of course your maximum. So it does make life a lot easier when we're doing statistics, right? So that's just a summary of everything, and here is your screens again. So we covered that on the calculator. It's just there for if you want the notes and you want to go back and check. Okay, now the next thing to look at is symmetric and skewed data. So symmetric data is data where your first half of your data looks like a mirror image of your second half. So this here, it's a perfectly symmetrical ghost. You can see there's a mirror image of the two. And your median is equal to your mean. Okay, so they're at the same point. When it is right skewed, it means your tail of your data is flowing off to the right, but your peak is on the left. Okay, so don't confuse yourselves. So your mean is the highest point, is bigger than your median. And you can also call this positively skewed. Okay. Then, of course, your left skewed tails off actually to the left, but your hump is on the right-hand side, and we can call this a negatively skewed distribution. Your mean is less than your median. In other words, your average is showing you that there's more data towards the left-hand side than there is data to the right-hand side. There just are a couple of higher values. Okay, and those values skew your information, which is why it's called left skewed and right skewed. Cool. Oh, I see I missed one. Awesome. Alrighty, so from that, we can just look at what an outlier is. An outlier is a data point that doesn't seem to fit in with the other points. And from our picture, you can see here, he's very far away. We've got a very beautiful, strong relationship going on here. And then there's this little blue dot that has decided that it doesn't fit in. And this is something that we need to look at for your box and whisker plot as well. But what an outlier is, there can be two options basically. Either there was a mistake in your data and that's why this has happened, or otherwise there was an exception to your rule. So somebody who doesn't fit the pattern. And you need to go back and look and check your data and make sure that that isn't something that is a mistake. Okay, so if you are looking at analyzing something in particular, then that's something to be aware of as well. So how do we find our outlier? So we look for our interquartile range. Now, interquartile range is just a fancy thing for saying the range between quartile 3 and quartile 1. It is the range of your box in your box and whisker plot, okay? Then we find the lowest possible allowed value. So when we're looking for outliers, we are looking for values that don't fit in to these formulas. So our lowest possible value is quartile 1 minus 1,5 times your interquartile range. And of course, your highest possible allowed value is quartile 3 plus 1,5 times your interquartile range. So from the handbook and study guide that I referenced earlier, here is an example, and then we are looking to see if there are any outliers. So the first thing that we need to do is find our median. So we count how many data positions there are. 1, 2, 3, 4, 5, 6, 7. So 7 plus 1 is 8. 8 divided by 4 is 2. Sorry, that's quartile 1. 8 divided by 2 is 4. So 1, 2, 3, 4 is 11. So our median is 11. Okay. Then we look at our quartile 1 position. Here is 8 divided by 4, which is 2. So that's 9. And then quartile 3, we have 8 times 3 is 24, divided by 4 is position 6. So 1, 2, 3, 4, 5, 6. And quartile 3 is 14. So our interquartile range is 14 minus 9, which I believe I've actually got on my next slide. So let's just go look for it. So there we go, it's 5. And then we just fill in our data using our formula. So quartile 1 is 9 minus 1.5 times 5 is 1.5, ironically. And our highest possible allowed value is 14 plus 1.5 times 5, which is 21.5. Now, if we go back and look, our minimum was 8.5 and our maximum was 15. So those values are well within our allowed range before it becomes an outlier. If there was a data point that said 23, then we would know it is an outlier. Okay, so that's how we know when something doesn't fit into the pattern, when you're looking specifically at a box and whisker plot. So we're on to the very last part of our statistics, and this is our bivariate data and our scatter plot. So bivariate data is basically a relationship between two different variables. Okay, so between your x and y, can be between weight and height, which is what this example shows you on the right-hand side. And then just remember, this was drummed into me at varsity, correlation does not imply causation. So basically, that's a very fancy way of saying, just because there is a line and a straight line graph and it looks like there's a strong relationship, it doesn't mean that one has any effect on the other. So if we look here at our weight and height, we have a generally positively increasing line. It's sort of, if you squint your eyes, you can see a line going through there. But it doesn't mean that because you are so tall, you will weigh so much. One does not have any effect on the other. Yes, there might be some relationship to it because taller people might have heavier bones and more bone, so they might be slightly heavier. But you can have very short people, like over here, who are quite heavy as well. So you cannot imply that your height is the cause of your weight, when you cannot imply that the weight is the cause of your height. Okay, vice versa. So your x variable is always the one that goes on the bottom of your, on the bottom of your graph here. Okay, and your y is this one on the left hand. It's your height or your weight category, and it's usually what, so your x value is what is being manipulated or changed in the experiment or the observation, and your y value is what changes because you changed your x value. So when we change our year, then our whatever happens year to year will change as well, and so that would be your y value. Okay, so then we need to look at the relationship between the various scatter plots. Okay, so here at the very top, I'm just going to pull out a so here we have a positive relationship. This you should know from straight line graphs. Okay, if it's going from the bottom left to the top right, it is a positive relationship. If it is going from the top left to the bottom right, it is a negative relationship. As one increases, the other is decreasing. With the positive, as one increases, the other increases. So they're both increasing at the same time. Now, when you have a very strong relationship, most of your dots will be on the line. If you have a weak relationship, you can see the dots are sort of spread out and around the line. So it's, you're sort of seeing a pattern, but not really. That's weak. If you can see no pattern, which is down here at the bottom, then there is no relationship. So your correlation will be very low. So that leads us to correlation, and correlation measures the strength of your relationship. It lies between the value of -1 and 1. So when R is, or your correlation is between 0 and 1, your relationship is positive. And the closer your R value is to 1, the stronger your correlation, and your relationship is. So here, again, if we look here, you can see a very strong relationship. And then if we look at your 0,4, you can see there's lots of dots. So not a very strong relationship. But here the dots are much closer to the line and less spread out. When your R is between 0 and -1, the relationship is obviously negative. So it's this one here. And then, of course, again, the closer your R value is to -1, the stronger the negative relationship will be. So here you can see it's very weak. The dots are all spread out. It's difficult to tell what sort of line there is. Whereas here, the dots are your dot points are much closer together. And you can see that there is a general negative straight line trend. On the very first one, you can see there's absolutely no trend at all. The dots are spread all over the place, and so there is no relationship between the 2 points. So, one of the most important things you need to be able to do for your matric final paper is to be able to find your regression line. And we've made this really, really easy for you. So, let's grab my calculator and just move it to the side so I can see what I'm doing. So we have we need to first go to our stats mode with the straight line or the linear regression, which is number 1. And then you'll see you have a table with an X and a Y and a frequency. So you can either do this as in typing all the X's in first, press equals after each position, and then go back and type in your Y. Now, I think this takes a long time and I like shortcuts, so I'm going to show you a shorter way. So we can press 5, this button over here, X, Y, and 75, and equals, and there we go. Just puts the data across the table for us very nice and quickly so that we don't have to go backwards and forwards. So the next one is 3 and 73 and equals. Then we have 3 and 69 and equals. 4 and 86 and equals. 2 and 47 equals. 6 and 89 equals, and then I think on the other side, yes, there's 1 and 22 equals, and the last one is 4 and 72 equals. Okay, so from here, what we're going to do is we're just going to press our change button. So change will just change between your screen, your calculation screen, which is this one, and your data. So you can go back and edit and change anything that you like on the data screen. You can also press on if that's something, but change is nice because it goes back between the two of them. Now let's find our regression line. So again, we're going to use alpha and 8. And here you'll see now there's no longer a little stripy line at number 1. It says regression value instead of the stripy line. So we're going to press 1. And there we go. So our A value, in other words, our Y-intercept is 28,83333. Our gradient, or B, is 11,18. Okay, and then our correlation coefficient is 0,85. So in other words, it's a very strong positive correlation. All right, let's go back here. So this is all the steps. I will send you the notes, maybe not tomorrow, but definitely by Monday. So one of the things that we now need to look at is interpolation and extrapolation. And basically these are very fancy ways of saying to look for the data between the range of data that's being given to us versus to look for a data point outside of the range that is given to us. So inter means inside and extra means outside, exit. Okay, so that's the way to remember them. Normally, they don't actually use the words inter and extra extrapolation, so don't panic too much about it. They'll just say, please, can you predict a particular value? Okay, so if we look, we're going to go back to our calculator, and it's going to say, if x is 5, what is the y value? Okay, so if x is 5, we need to find our y. And you can see above your open and closed brackets, there are little orange x and y's with a little hat, and that means predicted x and predicted y. So we're looking for the predicted value of y. So we're just going to say second function and our close bracket button, and then it calculates the y value when x is 5. In other words, according to our straight line regression formula, if you study for 5 hours, you should get a mark of 84.75%. Now, we can also do it the other way around. So if I want to get 99%, how many hours do I need to study in order to do that? So I can say second function and open brackets. And there we go. So it's telling us we need to study for approximately 6 hours. I'm going to try and do some magic here. Sorry, I didn't think that would work. So it's telling you 6 hours, 16 minutes, and 27 seconds, if we want it to be really fancy. So that's just a really nice shortcut and something nice to know. Awesome. So that's us, guys. Thank you so much for joining us for this. What I want to tell you now is just briefly about the Future Fund 2.0. So all of these webinars that we've been doing over the last couple of weeks have been in aid of the Future Fund. And what we're trying to do is to raise money for kids who don't have their own calculators. So if you know somebody who needs a tax break, you can donate. It goes through an NGO called CASME, and you'll be able to get a tax certificate for that, just as a side fringe benefit. But also, you will be helping kids do better at maths. So if you look at the research, it shows that a matric exam paper, you will lose 25% in a matric exam paper if you do not know how to use a calculator or have a calculator. So that's a huge chunk. I mean, that's the difference between a pass and a fail and getting into a degree that you actually want to do, or doing something else entirely. So it's a really critical to get calculators into the hands of students who cannot afford them. Awesome. I will send a Zapper donation link tomorrow or Monday with the results. So thank you very much for joining us. Remember that you can download those free worksheets for maths, math literacy, and technical maths from maths@sharp.co.za. You just need to register as a maths teacher. They are all free. They are all South African. They were written mostly by me. So if you spot an error, please let me know so that I can go and fix it. But yes, so thanks very much for joining us, guys. I hope you've enjoyed your time with us. And